All right, welcome to Unit 5. This is Ratio and Proportions, Lesson 1. So ratio is a comparison of two quantities. The ratio of A compared to B can be expressed in three ways: in words, ratio notation, and as a fraction. So how you say this is A to B. So here's an example. Tanya's got 3 hats and 2 scarves. So we can write the ratio of hats to scarves in words. And that's going to be 3 hats to 2 scarves. In ratio notation, 3 to 2. And as a fraction, 3 over 2. You can also compare the scarves to hats. So this would kind of be in reverse. In words, you've got 2 scarves to 3 hats. And in ratio notation would be 2 to 3. And as a fraction, 2 over 3. Now you have to be careful. Order matters. So as you're reading the sentence here, you're comparing hats to scarves. So there's 3 hats and 2 scarves. So you cannot write this as 2 to 3 because you would be comparing incorrect things in the wrong order. So order is going to matter here. So let's take another look at this next example. So what I would do is I'd pause the video and then fill out the information and then click play and see if you've done it correctly. So here, we got to count. We've got 3 of these black ones and we've got 5 white. Okay, so let's compare it in all 3 ways. So the first thing is we're comparing black to white. So we need to do it in the correct order. So you would say 3 black to 5 white. And in ratio notation, that's going to be 3 to 5. And as a fraction, you're going 3 over 5. Now the next one on the right here is comparing white to total. Well, what's the total number that we have? 3 plus 5 equals 8. That's our total. So when you're kind of reading these, you can almost put notation above it here, like we're comparing 3 to 8. So in words, this is going to be 3 white to 8 total. And in ratio notation, we're going 3 to 8, and as a fraction, 3 over 8. So here's another example. So pause the video, write down what you think it's going to be, and then click play and see if you're correct. So just looking at what we got here, it looks like we've got 5 black squares, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 white. So let's compare the black to white using words. So we have 5 black to 10 white. And in ratio notation, 5 to 10. And as a fraction, we got 5 over 10. Now, you can reduce these the same way that we reduce fractions. So this is going to be 1 over 2. So you could compare that as 1 to 2. Now we're comparing white to black. Well, this is going to be in reverse. So we have 10 white to 5 black. And it's going to be 10 to 5 or 2 to 1. And it's going to be 10 over 5. That's 2 over 1. Or simply 2 in this case, which means we have double the amount of white than black. So a proportion is an equality of 2 ratios. We write proportions to help us establish equivalent ratios and solve for unknown quantities. So a recipe calls for 1 cup of flour for every 3 cups of 1 cup of water for every 3 cups of flour. If Sean follows the recipe and uses 6 cups of flour, how many cups of water does he need? So in the recipe, the ratio is 1 to 3. So to follow the recipe, Sean's water to flour ratio also must be 1 to 3. So what we're going to do is we're going to rewrite the ratio as a fraction. So 1 to 3 becomes the fraction 1 over 3. Now you got to look at this. If we're looking at the different parts, and in the information we're given that Sean wants to use 6 cups of flour. Okay. In our ratio, the flour is the second part of the ratio, So that's the denominator of your fraction. Okay? Now, if we're talking about flour as well, that's also going to be the denominator of your fraction on the left, and it's also going to be the denominator on the fraction of your right. Now, 1 is going to be the numerator on the right, and the thing that we're looking for is the unknown. How much water does he need to use? So, when we get to this stage, we can use a one-step linear equation to isolate the unknown variable. So I'll show you this two ways. X over 6 is equal to 1/3. Now, you might simply go, well, this is multiplied by 2, so if I multiply that 1 by 2, x should be 2, which is fine and dandy. But let's solve it algebraically, because the numbers might not be so nice in further examples. So we want x by itself. We don't like the denominator here. So let's simplify to 1, which means we're going to have to multiply by 6. So if you multiply each side by 6, you're going to get x is equal to 6 over 3, because 1 times 6 is 6. And 6 over 3 does simplify to 2. So x equals 2, so that means we need 2 cups of flour. Or sorry, 2 cups of water, not 2 cups of flour. We got the flour already. So let's solve for some unknown variables here. 80 over 25 equals x over 45. So x is what we're looking for. So we need to simplify the denominator. So we're going to multiply each side by 45. 45 divided by 45 is simply 1. So you're going to be left with x on the right side. Now 45 multiplied by 80 divided by 25 is going to simplify to 144. So x is equal to 144. And you can test this out. 80 divided by 25, is that equal to 144 divided by 45? So you could check that on your calculator. You would type in 80 divided by 25, and you would type in 144 divided by 45, and you'd see what you get. I'll let you do that one. Here's another one. M over 15 equals 78 over 18. So we need to multiply by 15 to isolate m. And what we're doing to one side, we're going to do to the other. So that simplifies to 1, and you get m equaling 78 multiplied by 15 divided by 18, which is 65. So again, you can check this on your calculator. 65 over 15, you would type in 65 divided by 15 and see what value you get. And 78 divided by 18, see what you get. And these, whatever you get there, should be the same. All right, this one's a little bit trickier. We have two different, we have variables on both sides, and we have two different denominators. So, like in our linear equations unit, let's multiply by the unique denominators here. So we're getting 7 and 6. We're going to multiply both sides by 7 and by 6. Well, on the left side, the 7's simplify to 1, so you're going to be left with 6 multiplied by d, which is 6d. And on the right side, the 6 simplifies to 1, so you're going to be left with 7 multiplied by d plus 2. Using the distributive property, 7 multiplied by d is 7d, and 7 multiplied by 2 is positive 14. Now we need to go ahead and solve this. So 6d is less, so I'm going to subtract 6d from either side, and that makes a 0 pair. Now 7d minus 60 is d, and now we need to solve for d. So we're going to subtract 14 from each side. And we get negative 14. One more example here. Let's multiply by 9 and by 6. On the left side, the 9's will simplify, and on the right side, the 6's simplify. So we're going to be left with 6 multiplied by p plus 12 is equal to 9 multiplied by p plus 7. So 6p plus 72 is equal to 9p plus 63. And 6p is less, so let's subtract 6p from either side. The left side will simplify to 0, so you're going to be left with 72 here. And then 9p minus 6p is 3p. And then we're going to subtract 63 from either side. And 3p equals 9. One more step here, divide by 3, and p is equal to 3. All right, let's use proportional reasoning to answer the following questions. The ratio of the length to the width of a rectangle is 5 to 2. So remember, the words in the sentence are in the same order as the ratio, so that means that that's length to width. If the rectangle is 24 centimeter wide, so we know the width, how long? L is the unknown that we're looking for. So let's start with the unknown that we're looking for, L, which is this part, and that's going to compare it to 24. And we also have the ratio of 5 to 2, which is length to width. So let's create two fractions here. The first one's going to be L over 24, and we're going to set that equal to 5 over 2. We want to simplify for L, so let's multiply each side by 24. And L is going to be 60. A boat can travel 320 kilometers on 64 liters of gas. So the ratio we're going to create is kilometers to liters. So how much gasoline will it need to travel 400 kilometers? So we're looking for liters, and we know the kilometers. So let's create a fraction. The liters, which is the unknown that we want, over the corresponding kilometers. So this liters here goes with this amount of kilometers. And we're going to compare that to another fraction. So on the fraction on the left, we have liters on top. So we're going to put 64 over 320. Can you see that we have liters over kilometers on the right side, and we have liters over kilometer on the left side? Okay. So we want to isolate for the L. So we're going to multiply each side by 405. So the amount of liters that we need is going to be 64 multiplied by 405 divided by 320, which works out to be 81. So the amount of liters is going to be 81 liters. 29 kilograms of apples cost $174. How much would it cost to buy 15 kilograms of apples? So we're looking for the dollars, the amount of money. And we know the kilograms of apples. So let's put X dollars over 15 kilograms is equal to $174 over 29 kilograms. Now these are units, they're not variables. Don't get confused with if something's a variable. So typically when we're working out stuff, we don't use the units in the calculations. So we want to get the X number of dollars, so we're going to multiply each side by 15. So the X number of dollars is going to work out to 90. That's 174 multiplied by 15 divided by 29. All right, one more example. The ratio of fiction books to nonfiction books in Roxanne's library is 7 to 4. So we have fiction to nonfiction. If Roxanne owns 182 fiction books, how many nonfiction books does she own? So here you could do 7 over 4 is equal to 182 over X. Now one thing to note here, if we reverse the order, if you compare the nonfiction books to fiction, that would reverse your proportion statement. Okay? Now, you can also do that with your fractions. 4 over 7 is the same as x over 182. And that's a little bit easier to solve with the variable in the numerator. So I'm just going to rewrite that over here. We want to isolate for x, so multiply each side by 182. And x is going to equal $104.